Today's lesson is on solution preparation and dilution and solution stoichiometry. These three topics are all first-year chemistry topics, things you should be familiar with. And so we're going to go through some practice problems today. You should pause this video to work all the problems and then to check my solutions with your answers. So the first thing we're going to talk about is how to make up a solution. We want to make 2 liters of a stock solution of 0.750 molar potassium dichromate. We have solid potassium dichromate powder, a 2-liter volumetric flask, water, and a balance. How would you prepare this solution? So you know that there's a calculation involved, but there's also a verbal description that you want to give whenever talking about making solutions. So I would like you to pause the video while you solve this problem, and then we'll talk about how to put into words the process for creating the stock solution. So you should have calculated that 441 grams of potassium dichromate are required. You're going to take the 441 grams, place it in a 2-liter volumetric flask, add some water to dissolve, maybe about half of the water, get it to dissolve, and then dilute to the mark on the volumetric flask with deionized water. It's important to go through these steps. It is not sufficient to say dissolve 441 grams in 2 liters of water. Not only is it not sufficient, it's not correct. Because a solution, molarity represents the total volume. And so it's going to include the potassium dichromate and the water that's in there for a total volume of 2 liters. So be careful in your descriptions of solution preparation. I've seen this question asked before on AP exams, and it's important to understand the process for making a solution. So in the next problem, we're going to take that stock solution or a stock solution and make a dilution. And we have a very simple formula to work with when we're diluting solutions. And that is molarity of the concentrated times volume of the concentrated equals molarity of the dilute times volume of the dilute. And so when you're reading through any particular question, all you have to make sure is that you're substituting appropriately into this formula. So go ahead and set up that problem and then check your work with me once you're done. So the molarity of the diluted solution is 0.0667 molar. I put a star here next to the 30 milliliters, the volume of the dilute. Understand that the 10 milliliters that we started with is diluted with an additional 20 milliliters to get us to our final volume of 30 milliliters. Go ahead and set up problem number 11 and pause the video while you solve it. So the molarity of the original sample was found to be 1.17 molar. Again, it's only important to make sure you're substituting correctly into this formula. Sometimes people ask about the units that are used here for volume. Do you have to use liters because molarity is in liters? No, it doesn't matter what volume unit you use because you could see that it's going to calculate, or it's going to cancel out in this calculation. All right, let's go on then to problem number 12. So in this problem, I solved for the total volume of the diluted solution and subtracted out the original 10 milliliters of the concentrated solution. So therefore 15 milliliters of water must be added to our original solution. Go ahead and set up problem number 13. So in problem 13, I need to use 200 milliliters or 0.2 liters of the concentrated solution in order to get 2 liters of our desired concentration of 0.0100 molar. In order to do that, I'm going to take the 200 milliliters of the concentrated, put it into a volumetric flask, and add about almost 1.8 liters of water, at least up to the 2-liter mark on the volumetric flask to get the desired dilution. So you should be very comfortable calculating solution concentrations as well as making dilutions. Our next topic we're going to go through is solution stoichiometry. Essentially, these are stoichiometry problems where we're using mole ratios and molarity to calculate quantities. So we're going to look at a couple examples of these. Like any stoichiometry problem, we're going to start each problem with a balanced chemical equation and a quantity, and then we're going to solve for an unknown. So in 14, how many milliliters of a 0.2 molar barium chloride solution will be required to react completely with 350 milliliters of 0.15 molar sulfuric acid? So go ahead and write a balanced chemical equation. So once you have your balanced chemical equation, you go ahead and set up your stoichiometry problem. And you'll see in number 14 that we're using molarity both as a conversion factor at the top and at the bottom of this problem. Okay, so we're starting with a volume of sulfuric acid, 0.15 molar, and we want to know how much barium chloride solution we're going to need when that solution is a 0.20 molar. And so then you can go ahead and solve for your milliliters or your volume of barium chloride in that way. Okay, so this is a problem where it's molarity to mole ratio, back to molarity, and then volume. Okay, go ahead and set up number 15. We need a balanced chemical equation and a stoichiometry setup. So using our balanced chemical equation, we'll start with our 87.36 milliliters of hydrogen gas that are formed. And since this is at STP, we can use the molar volume of a gas to convert to moles of hydrogen. We use our mole ratio to convert to moles of HCl. We use molarity to convert finally to volume of HCl, which we can then express in milliliters. So we have a few remaining problems on page 8 of your class notes. And I just wanted to give you the answers to those so that you could try to work these problems start to finish and just check your final answer. So number 16 comes out to 577 milliliters of HCl. Number 17, mass percent. So in this one, you're going to have to calculate the mass of the oxalic acid and then the mass percentage of the total. And then you can skip 18 for a moment. It's not really a calculation. In number 19, I have an answer of 0.3670 molar for the sodium hydroxide. So these last two are acid-base titrations, really no different from the other problem types we've been doing. You're just going to need a balanced chemical equation to get started. So give those problems a try for the remainder of your classwork today, and you can check your answers, and you can check your work in class next time. Have a great day.